Seeing the manufacturing process of the earthquake-resistant giant pipe, I finally understood why a 1.8-meter worker dares to use a 3-meter-long iron rod to continuously poke at high-speed cement. Just one reinforcing rib of the pipe body requires double-layer laying, plus 360-degree centrifugal rolling, and 3 layers of concrete need to be poured before and after, directly doubling the earthquake resistance and durability of the cement pipe. Now let's take a look at how the giant cement pipe is manufactured. Workers first unload the truck filled with sand and gravel, which then follows the conveyor belt into the mixing station. The sand and gravel are the initial prototype of the concrete, which includes crushed bluestone chips, and a semi-finished product made from a mixture of sand and cement. Once all the materials have entered, the workers in the control room use real-time feedback from the cameras to intelligently mix each tank. This process often takes a long time. Meanwhile, let's move forward to take a look at the hooping process. Rebar is used to reinforce the rigid framework of concrete, and there is an unknown side to its production. The motor drives the rotating disc to turn at the same frequency, while on the other side, the current is converted into heat energy through resistance, and then the rebar is welded. At this point, the rebar becomes circular, and then the connection point of the rebar is cut open from one end. At this point, the framework of the cement pipe is completed. Then, the nozzle is taken out to start treating the mold. The layer sprayed by the worker is a release agent, which helps the cement achieve a smooth finish, fundamentally solving the problem of concrete adhesion and rough surfaces. The hoist is then activated, and under the guidance of the workers, the reinforcement is precisely installed. Observant individuals might notice that the factory uses 2 sets of rebar pre-installed. The main purpose of this is to enhance durability, as we all know that this cement pipe is formed in 3 stages. Each rotation stabilizes the concrete and rebar once each, and after 3 rotations, the concrete just covers the rebar. Then, workers remove the steel mold from the other side, moving and pushing it inward to ensure a tight fit, and use an air wrench to tighten each nut. As the mold is formed, it moves to the next step, which is the pouring process, the most crucial step in this cycle. Before starting the production, workers first activate the equipment, causing the 4 sets of rollers below to rotate the mold at the same frequency, while the conveyor belt at the back also starts immediately. It then transports the concrete into the mold. This equipment pours according to a preset program in proportion, meaning that the material used in each of the 3 times is the same. Moreover, after each pouring is completed, the conveyor belt above automatically retracts, which greatly prevents the issue of concrete drying. After rotating for 5 minutes, the mold stops, and the inside becomes quite compact. However, at this point, pouring cannot continue. Instead, a crane lifts it, and a long-awaited hose is used to spray water inside. You might find it surprising. How could you not believe it? The main reason for spraying water is to remove impurities, because during the rotation of the mold, what can bond has already formed together, and what cannot bond is nothing more than large stones. That's why water is used to wash them away. Only by operating this way can each layer be ensured to bond with each other. Otherwise, a layer would form due to those stones. Next, the manual processing begins, which is the most critical step in this round. Workers have to grip an iron rod under high-speed rotating equipment, using the friction from the rod to create sharp edges. Although the finished product looks impressive, you should know that the worker holds that iron rod for an entire day. If the arm strength is insufficient, it can cause the iron rod to fly out. But this is an essential process. Please do not attempt this if you are not a professional. At this point, the initial shape of the concrete pipe has been formed. Next, we move on to the next step, steam curing. The purpose of steam curing is to allow the concrete to solidify more quickly. Doesn't it look very solid at this point? The curing duration is generally around 6 to 10 hours, and it is crucial to maintain a constant temperature and control. This means that curing can only occur at a specific temperature. So, although it looks simple, it is actually not simple at all. Then, the air bubble is removed, and the mold of the concrete pipe is dismantled. Compared to the previous positions, this should be the easiest, as it only requires wielding the air hammer each day. Next, the hydraulic equipment is taken out. So this tool is very cleverly designed. With just a push, it can be easily dismantled. Then, it is moved aside to be used for making the next mold, and all the nuts on both sides used for securing must also be removed. Now comes the moment to witness a miracle. When the mold is slowly opened, a brand new shiny surface comes into view. In appearance, it is almost indistinguishable from traditional cement pipes. But on the left side, there are several distinct edges, used to connect with another set of pipes, fundamentally enhancing its durability. The most unique step is right in front of us. A nozzle is installed in the middle of the pipe, continuously spraying a large flow of water against the pipe wall. It is said that the main purpose of doing this is to prevent liver damage. Now let's take a look at this astonishing size. What do you think of this earthquake-resistant cement pipe technology?